All right, in this lesson, we're going to learn about end behavior. End behavior are what functions do when x's get radically large or radically negative. Okay, and we're always going to use what's known as a limit form to write the behavior of graphs at the end. So you'll see LIM, which means limit, and you're going to see x in an arrow, and you're supposed to put something here in this space, right? That's telling us what x is doing. And then you write the name of the function, an equal sign, and then in this space right here, you tell me what the y value is doing. So the translation of this, and we're not going to fill in the blanks on this one, as x approaches that number, the function named f of x, y value's limit is this number. So there's really just a few scenarios of end behavior, and we're going to go over all 8 of them. So the first 4 scenarios have one thing in common, and it's that the input is increasing without bound. Now the phrase x increases without bound means that the input gets larger and larger. Like it's getting really big. And that means that the x value is approaching positive infinity, headed into the extreme right. So what we're saying is we're going as far right as possible in terms of the x-axis. So let's take a look at scenario number 1. So here we have probably like something like x squared here. And my function, as my x values get more and more large, my y values for this graph are also getting larger and larger. The question is what happens if I go to the extreme right of the graph? Well, my graph is just continually going up, and up. So the way I would write this, and let me zoom in here so that y'all can get it here. I'm going to write that the limit as x approaches infinity, that means I'm going to the extreme right of function f of x, my y value is also headed toward infinity. And that is how we write the limit. Let's take a look at the next scenario. In this scenario, as my x's increase without bound, meaning that my x is going to the extreme right, it's headed to positive infinity. The y value on this graph is going down, becoming more and more negative. So the limit, as my x value approaches the far right to positive infinity of this function called h of x, and it's also very important that you use the name of the function here and you don't just write f all the time, right? The limit as my x approaches positive infinity of this function is headed down to negative infinity. Okay. So that is that. So here are 2 common end behaviors for polynomials. Sometimes you'll see a graph as we head toward the end of it becomes more and more flat. So my x values, if I were to head straight over there to positive infinity, my y values reached like a lower limit and my graph became flat. And whatever that lower limit is my limit for my function. And let's say it's 4 for this one, right? So as my x approaches infinity, my function r of x, the y value was dropping down. It passes 5, but my y value never goes past 4. So that is the lower limit for this scenario. So we have 2 scenarios where we were increasing without bound, decreasing without bound. And here we're flattening on an asymptote. Sometimes they don't show you the dotted line asymptote. Sometimes you have to kind of obviously see it, especially if you know it's an exponential function or a certain type of rational function. The final scenario is that as my x increases, right? I'm still headed over here on the x-axis. I'm still headed to the far right. That my y value has an asymptote where it's headed to 0, meaning my y value got smaller and smaller and smaller, but it never crosses the x-axis. In fact, this scenario is really the same as this scenario. It's just that my asymptote's not 4. My asymptote is the x-axis. So my limit as x approaches infinity of, what am I writing here? The name of the function d of x is 0. Okay. So these are when they become flat. I'm going to write that note on the side here. So when the lines become flat. So in all 4 of these examples, my x's were increasing without bound, meaning I was going to the far right of the graph. What if we look on the other end of the graph? Okay, and so we got 4 different scenarios here, scenario 5 through 8. So the phrase x decreases without bound is meaning that our input is getting more and more negative. In other words, my x value is approaching negative infinity. It's headed to the extreme left. So we're looking on the other side of the graph, right? So take a look at this polynomial here. I'm going up, up, up. So yeah, my y value is going up. That's very clear. But as I go to that direction, if I were to go to the extreme left, that number of y is just getting extremely higher, and it's happening really fast. So my limit, and this is the difference between this one and the ones above, now my x is going to the left. I'm going to say my x is headed to negative infinity for function k of x is equal to infinity. Right. Same thing over here. They're both headed in the negative direction. My x is headed to the extreme left, right? My y value is headed straight down. Well, not straight down, but it's headed down really fast. And so my limit as x approaches the negative infinity, it's because we're going to the left here. As I follow the curve, my pencil is going to the left. P of x is also negative infinity. Okay. All right, we have another asymptote example here. I have a function that over here it just goes down, it dips down, and then it goes up a little bit. But as it goes up, it won't go past that dotted line. That's an asymptote, right? And so how do we write that limit? Well, my x value, as we go along the graph, is going more to the extreme left. So my x is approaching negative infinity. The name of this function is g of x. And my y values won't go above that limit there. It's hitting that asymptote. Let's say this one's about 7. Okay? So it's a number here. Okay. Finally, another example, my function a of x, as I go to the left, and my x values are getting more and more negative, my function apparently is just not able to get past that x-axis. My function, when I go to the left, it will, no matter how far to the left I go, it doesn't drop below 0. So its limit is 0. Okay, and once again, these two scenarios were when they became flat.